Hello students, welcome to lecture of Kinematics and Theory of Machine. Myself Professor Shailesh Patel. We are going to continue our chapter gear, and it is the last theory of this chapter, and after that we will complete example based on this topic also. So today we will learn interference in an involute gear, okay, which is very important. Okay, let's start. Okay, our next topic is interference in involute gears. The phenomena when the tip of the tooth undercut the root on its mating gear is known as interference. So first of all, check what is the interference and how it's affect the working of gear. So you can see here the profile is modified and there is a curvature is added. So this tip of the teeth not cut the root of the mating gear. So check this definition again. The phenomena when the tip of the tooth undercut the root of mating gear. So you can see here the tip of this tooth is undercutting this root of the gear. So it is known as interference and also undercutting. So we will from this theory we will define what is the minimum number of teeth required to avoid this interference and how we can avoid this. So first of all we have to you can see that means we have to find what is the maximum addendum. If we decrease the addendum in this gear, the length will be less and this cutting will be less, and we can decrease by this finding the value of addendum. Okay, so it is, let's start. So this is the old figure for the length of path of contact. You know that this is the length of addendum, but what will be the maximum addendum can be possible? This addendum circle you can see here, but what can be the maximum addendum? The maximum addendum can be possible up to the point M. Okay, and if you increase the addendum length more than M, then there will be interference. So first of all we have to find what is the length can be possible, maximum addendum length. We have to find this maximum up to. So our contact point, our point of engagement will become at a M and N. So length of path of contact for maximum possible addendum will be Mn. We have already find this KL value, but it is the normal value. But what is the maximum can be length of path of contact will be up to this. This Mn will be maximum possible length of path of. So this figure you will see in a book, and first of all understand what is these notations. There is a base circle, it is a pitch circle. Actual circle means K point, we have find the KL as a length of path of contact for the actual addendum. But what is the maximum possible addendum? Maximum or possible addendum circle length can be up to this point M, and for this pinion that can be possible up to this. So length of path of contact for maximum addendum can be this Mn. Okay, so we have to find this O1n, addendum radius O1n. How can we find this O1n? So for that I am going to tell you some geometrical relation for this triangle. This triangle is O1Pn. In O1Pn you can say O1n is equal to under root O1P, this O1P square plus Pn square minus 2 O1P Pn cos O1P, which angle? Angle of opposite side, this angle. So this is from the triangle O1 P n. So O1 n square is equal to this O1 p square plus Pn n square minus 2 O1 p Pn cos O1 Pn. So what will be this angle? How can find? So first of all, check this geometry. If this angle is 90, this angle is phi. Here you can see this angle is 90. What will be the angle of this angle? 90 phi. Then it will be 90 minus phi. 90 minus phi. Okay. So this angle will be 180. You can say this angle is a 180 minus 90 minus 5. Okay, so angle will be 180 minus 90 means 90 plus 5. Okay, so check this out. So you can see O1p. Where is the O1p? This is the O1p. It is a small r, pitch radius of pinion. Pn means this. Pn is a what? You can see here the sine component of pitch radius of wheel, and same as a cos 90 plus phi. We have seen this. So this is the relation, most important relation, which is derived from this geometry. Okay, so we are going to derive whole equation here. Check this out. So first of all, we have finded this O1n r square plus capital R square sin square phi minus 2r sin phi cos 90 plus phi. Okay, you can see there cos 90 plus phi, 90 plus second quadrant, and then cos will be minus, so minus sin phi. Cos 90 plus phi is equal to minus sin phi, and you can see here minus will be became plus sin square phi. So formula will be r square capital R square sin square phi plus 2r capital R sin square phi. And from all this data you will common small r square. So 1 plus, there is no small r square here, so upon capital small r square there is 1 r already there, and you common the r square, so r will be there. So this is the, and after that from this two you are going to common r by r. Okay, capital R by small r, you will common capital R by small r. So what will happen? Capital R by small r here, and from this point r and small r is common. So that's how you will get this formula. From this you know that it is equal to O1n square. So what will be O1n? O1n is equal to, this is total in a root. Then what will happen means this r square become the r, and whole term will be under root. 1 plus capital R by small r under root capital R by small r plus 2 into sin square phi. So finally our equation is this. O1n means O1n is equal to r is equal to mt by 2. We have put it mt by 2 under root 1 plus, so capital R by small r, we can write this is equal to capital T upon small t. R by r is equal to capital Y. You know the gear ratio, because you know the T by T is equal to small d by small t, and this diameter you can written as a capital R 2r, and this diameter can be written as a small 2r. So 2 will be cancelled. It is a gear ratio. Okay, so this is the capital T by small t, capital T by small t, and So we have find the maximum possible addendum length. What is the maximum possible addendum length? Means O1n is equal to, you can write this maximum possible addendum. So first of all, we have to find the minimum number of teeth to avoid the interference. So I have to explain you what is the addendum radius. Addendum radius, you know that RA is equal to capital R plus addendum. You add some addendum, and addendum, you know that always in a form of module, means it is maybe 1 module, 2 module, 3 into module, 1 module. Okay, so it is always in a form of a module. You will always some multiplying something with the module and you will get the addendum. So in case we have changed this method and we have added one constant AP, so addendum will be always in a form of AP into M. So addendum is equal to will be AP into M, where AP is a fraction. AP is a fraction by which standard addendum of one module, means module is a multiply by with this AP. So what will be the maximum possible addendum? So addendum radius minus pitch circle. So AMP. So AMP is equal to O1n minus O1p, and both value will be added in this formula. So after that, MT by 2 and MT by 2 will be common from both sides. So MT by 2 is common. Here whole term is outside, so it will become 1. Okay, and MT by 2, M and M is eliminated, only AP will remain here. So AP is equal to T by 2 under root this, and you know that capital T by small t is equal to G. Gear ratio G is equal to capital T by small t. Okay, so what will happen here? So you can write the subject the whole equation as a T. Why? Because we want to find the minimum number of teeth. So T is equal to becomes 2 going to this side, 2 into AP, and whole term will be at a below. So it will become this equation, and in this equation T by small t is we are putting as a G, gear ratio. So this is the equation of minimum number of teeth on pinion to avoid the interference. What will happen if we decrease the number of teeth? Like as per this equation, if we find 15, and if as for 15 teeth size is this, because on this on that radius 15 is a number of minimum teeth required to avoid the interference. If I am making only 12 teeth on that gear, what will happen? That teeth will become larger than, means on gear as the number of teeth increase, the size of teeth is decrease. So as the number decrease, the size will increase, and larger the size, possibility of interference is high. Okay, so this is the minimum number of teeth to avoid the interference. And same as you can use derive for the wheel. Okay, so capital T is equal to AW here, AW for the wheel, 1 by G plus 2 sin square phi minus 1. And if G is equal to 1, what will happen? If G is equal to 1, this will 1 and 1. So 1 plus 2 is equal to 3. So 3 into sin square phi. And equation becomes simple. Okay.